Today's training is going to cover common toolpaths that we use on our ShopBots. Within the vCarve Pro or Aspire software, on the toolpath side, you've got several different toolpaths that we'll be looking into today and corresponding those with video of the machine cutting these. What we're going to see first here is the ShopBot desktop doing a profile toolpath. And just to see this thing in action before we go look at the software, a profile goes along the line of a vector, and you can set it to go to the depth all the way through or only to go down to a certain distance. So as you see, the first one was a through cut, where the second cut here is only going down half the distance. Now if you watch on this third cut, this is going to ramp down in instead of straight down. It ramps the Z movement down, and then along here where it picks up and drops back down, it leaves a tab. That's what keeps that square that's a through cut from going out. And here again is the opposing side with a tab, and now the machine will come back and clean up that ramp before it exits the material. What we just saw in the video was the machine cutting these three squares out, which was profile 1, 2, and 3. And the reason there's three different toolpaths because it was doing three different operations. The first one was a through cut, the second one was only partial of the way through the material, and the third one added tabs and ramps. If all three of these squares were going to be the same, I could highlight all of them and just click profile and do one toolpath. But since I did different operations, if I double click on profile 1, you can see this one had a cut depth of 0.25. I went all the way through the material, where on the second one here in the middle I only had a cut depth of 0.125. So for different types of cut depths or adding different parts to the toolpath is where you would have separate ones. And you want to get into naming stuff better than just profile 1, 2, 3, because if you have a list like this, it's going to be hard to fit. What was profile 2? So you could list, maybe that would have been better named as profile 0.125 depth and had that, so it's easier to come back and find these stuff. But just to look into this toolpath before is you have a start depth, which we'll cover last, which is how far deep into the material you start the cut. It has nothing to do with where you're zeroing. Your cut depth is how deep you're going to go. So I have a cut depth of 0.125 for this. And again, we just like last week's training, we did tool database. You could go in here and figure out, well, how deep can I cut per pass with this bit and this material? So please reference that. In a profile toolpath, you're able to cut on the outside, the inside, or on the line. And depending on how you drew your part is which option you would want. But as you click on these, you can see that it changes, shows you where that bit is. It's on the inside of that vector now, or it centers itself over that vector line. Again, depending on how you drew this. You also saw by the time we got to the pocket 3, where we have these T's for tabs that we've added, and those tabs leave a little bit of material there so that little square doesn't come flying out of there when the machine makes its full cut all the way around. This green dot here is the start point, and why that is being referenced is because we put a ramp on here. And a ramp, instead of just plunging straight down the 1/4 inch in the Z, it ramps to a 1/4 inch depth over a fixed distance. And you can choose different types of ramps for different types of cuts. But as this one you saw here had a 2-inch ramp, so when it started to plunge here, it took 2 inches to get down to the 1/4 inch deep, and then as we saw in the video, the machine went around and cleaned that ramp back out. That's a real nice for saving life of the spindle and bits, and a lot of bits aren't designed to plunge straight up and down, so adding a ramp to especially hard material is something very beneficial to do. And again, look into your bits and the material for doing that. And that's what we saw on the video for the basics for the profile toolpath, that'll get you going. And the next one we'll look at would be the second one over here is the pocketing toolpath. Watch as the machine comes up and does the same vector as it did in the profile toolpath. However, with a pocket, it takes everything out inside the vector versus the profile toolpath where it just rides the line. On a pocket, it takes everything out in between. So this is really nice for if you have holes of different sizes, you can use a 1/4 inch bit to say do the 1/4 inch, the 1/2 inch, the 1 inch hole without having to change the bit to those sizes. It will drill it out using the same size bit. Take a look at this patio chair. This is a good example of when do you want to decide between using a profile or a pocket toolpath. And this is just a trick of the trade. After cutting several of these chairs out, realize that this handle right here isn't the best to be cut with a profile toolpath, because what it has is 2 tabs on it to hold the piece from moving after it's cut and it being extracted up into the dust collector, or even breaking a bit. So let's look at the software of why a pocket versus a profile. Sometimes you got to start thinking about as a user. Back in the software, we see the handle with a profile toolpath, and with that type of material, that piece, that could break a bit, that gets sucked up in the dust collector, that could easily hit the fan and take your fan and knock it out of balance inside your dust collector. So it causes a world of hurt without the tabs, let's just say that. Well, after saying, okay, so we know that we need tabs for this, well, now we got to take a knife and cut the tabs out, or a router, and rough the tabs off. So we've got some time post machining it on the ShopBot. So why not make this a profile for this? Well, it's going to take a little bit longer because it's going to cut out that material. But if we look over here at the time estimate, to do the profile it takes 20 seconds. Leaves the tabs. Now you or me has to go and clean those tabs up and discard this. With the pocket, now it takes approximately 1 minute, so about 40 seconds longer. But that 40 seconds longer of the machine cutting that out, turning it to sawdust and sucking it away and leaving a no tabbed edge is a lot faster than what it's going to take for me to cut these 2 tabs out and round them over with a small little spindle sander or file. So just think about it, just an extra tip of sometimes going, would a pocket toolpath be better than a profile for certain parts? One last thing to look at in pocketing was notice these 3 holes that I said we could do with the same bit. Since all 3 of these vectors are going to get machined the same, just created one pocket toolpath. So if I double clicked on where I had pocket holes, you see all 3 are selected. So there's no sense of creating a separate toolpath for each one of these if they're all going to have the same parameters. So I just select all 3, create one toolpath, and hit calculate. I'm going just a little bit deeper because I want to make sure I get through my material and cut 10/1000ths into my sacrificial board. And then there I can preview that visible toolpath, and I see that just what we saw in the video. Next we're looking at a drilling toolpath. And notice how it goes down, steps up, and goes back down. What it's doing here is a peck drill. And the peck drill allows the chip to extract up out of the hole. So you have a setup in your software of having it just go straight through the material all the way, or again what it's doing here is pecking it, lifting up, and then returning down into the cut. And all the parameters to that can be set. Back here in the software, we'll take a look, hover over to the 3rd one here, which is the drilling toolpath. And a lot of these fill-in sheets look about the same. You have a start depth, which again we've left 0 so far, and we'll change that at the very last toolpath. But the start depth again is how far into the material that we want to start. We don't want to start cutting in the material because we haven't moved any material away yet. We haven't removed any of it. Cut depth, I'm going through. Again, select your bit, but here is where you can add or not add a peck drill, where you can set up the parameters for a retract, a peck depth, and you can play with that depending on the material you want. But it's nice to allow that to peck down, especially on deeper holes, and extract the chip out of there so you don't build up friction for your bit. Alright, we're looking at V-carving of text now. So I've switched it to a V90 bit for this. And common is a V90 or V60 we use typically for a lot of V-carving. But with that being said, there are different angles that are being used for different types of text and font. So what we have with the V-carve is, here's a script type font which has wider parts of the lettering. So notice the wider the part of the letter, the deeper the bit goes. So what it's doing is it's finding the vector, and the wider the vector is in certain parts is where it goes shallower or deeper. So when you have a really neat script like this type font, you can really get some detail using the V-carve toolpath. And it will calculate using the geometry of the bit and the size of the text how deep it all needs to go, and will give you warnings if it's going to go too deep. So here we're cutting the sign, the word welcome, and you can see that the spacing between the two welcomes are different, and I'm talking about in between each letter. The one on the bottom is more of a scripted where they're touching, and the one on the top's been brought apart as far as each text. So just looking at this real quick, you can see that it needs a little cleanup. The feeds and speeds weren't quite right, and that's a whole nother issue. But what we have here is the top one clearly says welcome with each letter not touching each other. But the bottom one has all of these scripted along here where they're touching each other. And this is something that we can set up in the text. But also notice the wide part of the font, how much deeper it goes. And you can really see the detail with the multicolored plastic. And the reason we saw the different spaces was because up on the drawing side, you can come in here to edit text spacing. And that's just a preference on how you want your text to look. By clicking in between, I can bring the letters together and have them a scripted look, or like I did along this top one by holding the shift key and I click in between, it shifts them apart. But to look more specific at the V-carve toolpath, what we have here is, again, our start depth has been 0. We're not starting down into material. We want to start from the surface of the material. No matter where we zeroed it, the final toolpath will show we need to start down in the mirror because it has been removed already. A flat depth is for when a V-carve or say even a pocket, it gets too deep that it's going to cut all the way through. If this was one big giant welcome sign and it was going to go too deep for our material, you could assign a flat depth of say, hey, only go this deep. And instead of trying to use a V-bit to pocket out where it's going to be flat in the middle, you can assign a small clearance tool, say like an 1/8 of an inch bit or so. So we don't actually set the depth if we're just doing regular V-carve, because again, the software is smart enough to know the width of this E here and the geometry of this bit, and it can calculate the depth. Alright, an inlay toolpath is really nothing more than a pocket and a profile being used. But using the toolpath for inlay, you don't have to worry about coming up with the radius of the corners for, say, this T right here. I drew it as square corners. Using this toolpath, the machine will figure out where it needs to round for your internal and your external corner so they match up. So as you see here, the bottom T was pretty much a profile toolpath, and what we're doing up top is a pocket. But instead of choosing profile or pocket toolpath, I use the Inlay Toolpath, which again here, it knows to add the parameters to make these fit inside of each other. Like we saw in the video, these T's don't have the round corners on them. They're just brought in, drawn, however they got there. With a simple pocket or profile toolpath, they're not going to fit each other, because coming on the inside and the outside, you're going to have to figure out the radius of the bit to make sure. Well, let the software do it for you. That's what this Inlay Toolpath option is for. You can do your male and your female part, whether it's a through or all just step down. These are your options. And again, it's going to look a lot like the profile or the pocketing toolpath, but what it does is, again, by using the radius of the bit, as long as you select the same diameter, it's going to come in here and it's going to be smart enough to know. So let me just highlight these two that we used, and if I turn on the solid, you can see that using these toolpaths, it has known to take off these corners to make it fit, where a regular profile toolpath, you'd have a nice 90-degree corner there. So use the inlay one, and it'll get the effect that you want. Another thing to remember is inlays. If you're going to pull this part out and put it in this part, the ShopBot will cut it so tight that it might not fit. So sometimes with these, you might have to go in and add a pocket allowance, which is a tolerance, to make that pocket just a little bit bigger. And again, play with scrap material of what you're going to be using before you cut your actual piece to just figure out the pocket size that you need and the allowance that you need to go with it. Our final toolpath we're going to look at is adding a texture to the project. So this texturing toolpath here, we see that we've already had our material pocketed out to a depth of 1/4 of an inch. So this is where we'll bring in a start depth of 1/4 of an inch. So again, we've already seen a pocket toolpath. Now what it's doing is it's going in and making that texture that we just saw on the wood sign. I'm using a 1/4 inch ball nose for this. A ball nose leaves a nice effect. And it's just going to sit there and make these different gashes, and you can preview this before you even get out to your machine to make sure you find the desired look. Well, what we just saw in the video of the ShopBot cutting, we can preview all that right here in the Vectric software before we even get to that point. So as you saw here, the first toolpath was a pocket 0.25. I wanted to get down into the material before I started my texture. So nothing different there than a pocket going 1/4 inch deep. And then for the texturing toolpath, I gave it a start depth of 0.25. Without having a start depth, and I had that at 0 when we previewed it, we would see nothing, because there had already been 1/4 of an inch cut away from the pocket. So that's where this is when you have your profile and your pocket toolpaths. When it's asking your start depth, it's asking you how far down in the material you want to start. With the texture toolpath here, the third one over on the second row down, you can come in here, select your ball nose or whatever size type bit you want, and you can come up with your own pattern. And this is great because you come in here and you set the length of the cuts, maximum, minimum, the cut depths, and the overlaps. And when you have one that you really like, you can save this and have it as a texture that you can come back to later on. And you also can then say, oh, I remember I had that one that I wanted that was a great hand carve, and you can go in there and bring that in, and it brings up all the parameters. So also notice here what this boundary vector offset is, and let's go preview the toolpath so you can see what I'm referencing when I say boundary vector offset. With 0 and you're pocketed down there, you're going to have an issue. With our texture, we put in a 0.13, and I'm going to show you this in the preview mode. So the first toolpath was the pocket, and it pocketed it out, and again, it's showing you exactly what you're going to see on the machine, so spend the time here and check it out. There's an 1/8 of an inch deep, picks up, goes to the next, and it's going to go down next one more setting, and there's our quarter inch deep pocket. So now that we're down 1/4 of an inch, this is where we wanted to add our texture. So I select that, and I go preview visible toolpaths, and I can see that it lands that texture in there, and it looks great. However, what I'm also looking at is that boundary offset. When I'm down inside of a pocket like this, I need to add that boundary offset so I can keep my smooth edge right here. And that point that I had on there leaves that right there as your offset. If I was to go back in here and say no offset, and again, I use an offset that is at least the radius of your bit. So if we went in here and had 0, 0 and calculated that, and I go preview visible toolpath, it's going to come in there and damage your edge. So that's where I'm pointing out the boundary offset when you're pocketed down there like that. And thank you for coming today and seeing the basic toolpaths both in the software and on the machine, and getting a glimpse for looking into more details of each toolpath. Please come up and visit under Help Contents, and you can see each toolpath broken down more in depth. You can also visit these different websites and links for different training tutorials and videos in depth on each one specifically. Thank you very much.